Hi everyone, today we'll look at Orca2, teaching small language models how to reason. So, um, so the generations of a pre-trained model can be improved by instruction tuning. And instruction tuning essentially consists of fine-tuning the pre-trained model with natural language instructions and the desired output. So typically, in order to train small language models, you have a bigger model like a GPT-4, which is presented with inputs, and then the responses of the bigger model are used to train your student language models, thereby leveraging the information from the bigger language model. So it's been seen that with such kind of instruction tuning, sometimes the smaller language model basically learns how to mimic the style of the larger language model, but then the eventual answer is wrong. So to address this, we have explanation tuning, where instead of just fine tuning your smaller language model on the NLP instruction and the output, you also have a detailed response from the larger language model. And the way to elicit these detailed responses are through system instructions. And these could be things like these are prepended to the prompt given to the larger language model, and things like think step by step, generate detailed answers, etc. So, in a way, you're basically showing the language model how to think like a bigger language model. And it's been shown that bigger language models are better in reasoning about problems. So you're sort of getting that advantage in smaller language models. And also, depending on the kind of prompts or the system instructions you're giving to the language model, the output is different. And to get the right output, you probably would need a unique set of system instructions to be fed to the bigger language model. Um, so, so essentially, for a particular task, there is a system instruction which can give you the right response. And so they basically use this information for training smaller language models. So the way they train Orca2 is by eliciting responses from GPT-4, but to do that, they basically follow these steps. So they start off with a list of diverse tasks, and they use the outputs from Orca, which is a predecessor to Orca2, to decide what is the best system instruction for a particular task, whether it could be, just coming to the direct answer, or it could be generating step-by-step responses, reasoning instructions, or it could be explain and then answer sort of system instruction. And once they have this, they basically use this to get the responses from the bigger model. These are the teacher responses for a particular task with the system instruction which is prepended to the prompt. And once they do this, they then would have to take the responses from the teacher model to train their student model or the smaller language model. Now here what they do is they basically replace the system instruction with some generic one. So the smaller language model does not really see what system instruction was used for the teacher's response, with the hope that the smaller language model can basically learn how to map what kind of steps it has to follow to generate a particular response once it's fine-tuned. And so they call this technique as prompt erasing, because they essentially remove the prompt, which was the system instruction which was used to elicit response from the bigger or the teacher language model, and then they use that for training the smaller language model. And they call this model, which is trained in such a way, as Orca2. And they have around 800,000 training instances in their data set. So the source for these tasks, etc., are from Flan v2. And also, they have some examples from the Orca1 dataset, which has the explanations to natural language instructions. And then they also sample some math problems from these data sets. And they also have fully synthetic data, which is generated from GPT-4. And here are some training details. So they train Orca2 from the pre-trained Llama 2 7 billion or 13 billion checkpoint. And they train 5 million, and they also use the ChatGPT data from Orca 1 for a few epochs. And they primarily use, like what was seen before, they use a train split of the FLAN V2 dataset for one epoch. And then finally, they basically fine tune on the dataset which they mentioned before, where they are getting the response from a teacher model with some system instructions. And for tokenization, they use the Llama BPE tokenizer, and they add the pad and the start and the end tokens as well to the existing vocabulary. And to make sure that they use the resources efficiently, they use the packing technique where instead of adding padding tokens, they basically add inputs from another sequence, right? And while computing the loss, they only compute loss on the tokens which are generated by the teacher model, not all the tokens in the input. And the baselines they use are Llama 2 models, which is the 70 billion chat, 13 billion chat model, and Wizard LM, which is another instruction tuned version of Llama 2. And it has a 13 billion and a 70 billion variant. And Orca 1, which is the predecessor to Orca 2, which was trained through explanations from a larger language model, and GPT-4, which is ChatGPT and GPT-4. And they have a bunch of different, they evaluate their model on zero shot settings, and they have a bunch of different capabilities which they test for. Um, the reasoning capabilities of the model using these data sets, the understanding capabilities using these data sets, the text completion, the safety and the truthfulness, etc. And some of the results they find is by training in such a way, they find that Orca 213 billion significantly surpasses models of the same size, like Llama 2 Chat 13 billion and Wizard 13 billion. Um, and also, they find that Orca 2 is competitive with Llama 2 70 billion and also Wizard LM 70 billion. So, so basically, they say instead of just fine-tuning the model on instruction data set or explanations, using such a methodology helps them get better performance, right? So one thing that basically stood out in the limitations is that so when you have bigger models, they have gains with few shot learning, where essentially you have a bunch of demonstrations of the task, and the model basically learns how to perform the task with these demonstrations. But then you see that it's not, you don't see the same gains in performance when it comes to smaller models. So smaller models basically tend to perform better in zero shot settings versus few shot settings. And yeah, so basically, this paper shows how to leverage the reasoning capabilities of larger language models by this method of prompt erasure, where you erase the system instructions which were used to generate responses from the teacher model. And you hope that the smaller language model basically learns what strategy it has to use to generate responses for a particular task.